Assalamu alaikum, dear students. I'm your teacher Gr11MS. Here we are again in our math session with our lesson Limits and Continuity. Part 1b. At the end of this video, you will be able to recognize and use some properties of limits and find the limit of a polynomial function at infinity. Before we start, please try to prepare your textbook, your pens, draft papers, copybook, and your calculator. First, let us talk about the properties of limits. Suppose we have f and g are two given functions where k is a non-zero real number. A can designate plus infinity, minus infinity, or any real number. The first property, that the limit as x tends to a of f of x times g of x is equal to limit of f of x as x tends to a times limit of g of x as x tends to a. The second property, if we add or subtract two functions, the limit as x tends to a of f of x plus or minus g of x is the limit of f of x as x tends to a plus or minus the limit of g of x as x tends to a. While the limit as x tends to a of the rational of two functions, f of x over g of x, is the limit of f of x as x tends to a over the limit of g of x as x tends to a. The last property, the limit of a constant number times f of x as x tends to a equals to this constant times the limit of f of x as x tends to a. Now, to recognize operations on limits. Given c is any non-zero real number, and we have the product of two infinities having same sign is a plus infinity, while multiplying two infinities having different signs is minus infinity. Plus infinity exponent n tends to plus infinity where n is any natural number. Any constant number times plus infinity is a plus infinity if this constant number is positive, and it's minus infinity if this constant number is negative. Plus infinity over any constant is plus infinity if this constant is positive, and minus infinity if this constant is negative. Don't forget that radical of plus infinity is plus infinity. Now, plus infinity tends to plus infinity, and minus infinity tends to minus infinity. Where plus infinity plus constant is plus infinity, also plus infinity minus any constant tends to plus infinity. Now, minus infinity minus any constant or plus any constant will still minus infinity. Pay attention, plus infinity minus infinity will tend to what? Minus infinity plus infinity tends to what also? These are called indeterminate forms and symbolized by if. Now, let us find the limits below. The limit of minus 2x cubed as x tends to plus infinity. It is the limit as x tends to plus infinity of minus 2 times plus infinity exponent 3, which will tend to minus infinity. Another example, the limit of x cubed plus 2x as x tends to plus infinity is the limit of x cubed, which is plus infinity to the exponent 3, plus 2 times plus infinity will tend to plus infinity. A third example, the limit as x tends to plus infinity of minus 2x radical x. We have minus 2 into plus infinity, which is minus infinity, times radical infinity, which is infinity plus infinity. The result will be minus infinity. the last example, limit of x exponent 5 plus x squared as x tends to minus infinity is minus infinity plus infinity, which is an indeterminate form. Now you have your application. Find each of the following limits. Please excuse me. Pause your video to solve each one. Now, how to calculate the limit of a polynomial function at infinity. Let p of x be a polynomial function defined on the real set R as p of x axn plus bxn minus 1 plus c, where a is a non-zero real number, a, b, and c are real numbers, n is a natural number. The limit of p of x as x tends to plus or minus infinity, by taking xn as a common factor from this polynomial, we'll get limit of xn into a plus b over x plus c over xn as x tends to plus or minus infinity. Don't forget that c over plus infinity and c over minus infinity tends to 0, where c is any real number. So b over x tends to 0. C over xn also tends to 0. There's still only axn, so the limit of axn as x tends to plus or minus infinity is plus or minus infinity. And this way is said to be leading term method. Now the example, calculate the following limits. The limit of x cubed minus x squared as x tends to plus infinity is plus infinity minus infinity, which is indeterminate form. So, according to leading term method, this limit equals to limit of x cubed as x tends to plus infinity, so it's plus infinity. Another example, the limit of 5x4 plus x cubed as x tends to minus infinity is a plus infinity minus infinity, which is also indeterminate form. Also, by leading term method, we'll get this limit equals to limit of 5x4 as x tends to minus infinity, which is plus infinity. Now, our application. Please, for each one of these exercises or limits, please pause the video to solve it. Also, please pause your video to solve this limit. The summary of this lesson till now. First, let k be a strictly positive real number. A prime are two real numbers and non-zero numbers, where k belongs to R, k positive. Let L be any real number. Don't forget that any constant L over plus or minus infinity tends to 0. 0 over plus or minus infinity tends to 0 times 1 over plus or minus infinity tends to 0, which means that 0 over plus or minus infinity tends to 0. And don't forget the leading term method. And here is your assignment. Don't forget to do it, please. Coming next, how to find the limit of a rational function at infinity and how to find the limit of a function at infinity. See you soon, dear students. Goodbye.